right, mathematicians, we're going to do some more work with graphing and solving compound inequalities. Again, teachers really like these because you're kind of doing two problems in one. So yeah, we kind of like it. Let's do it. So this first one is an and statement. They're joined. And so my whole goal is to get x by itself. And how I do that is I add 3 to all 3 parts. Okay. So -2 plus 3 is 1. These cancel out and it's x. 4 plus 3 is 7. Then I bring down my signs. 1 is less than or equal to x, which is less than 7. 1 and 7. Okay. And then we shade in the middle. We shade in the middle. The second one is also an and statement. Again, we're trying to get g all alone. So I'm going to subtract 4 from all parts. So -2 is less than or equal to g, which is less than 3. Okay. And so that's solved. I have g all by itself. So I put my lesser number to the left, right, or greater number to the right. And then I check to see if I should fill them in or keep it open. This first one's a filled in dot because it has the line underneath. The second one's an open dot because there's no line underneath. It's an and statement, and I shade between. These next two are or statements, which means they're 2 for 1. We got to solve both of them in order to solve the one problem. So I'm going to start by subtracting 6 from both sides. So r is less than -14. I'm going to add 3 to both sides. R is greater than -7. And so when I plot these, I always put the lesser number on the left, the greater number on the right. Like any number line that you've ever done, the lesser numbers are on the left, greater numbers are on the right. In this case, they're both open circles. And because it's or, they go apart. Okay, so that we're going to shade apart rather than together. So I'm going to shade to the left, and I'm going to shade to the right. All right, one more here. Again, this is a twofer. You have to solve both inequalities to get it by itself. So a is less than 3. Add 1. A is greater than or equal to 4. Lesser number on the left, greater number on the right. Open circle on the 3, because a is less than 3. Filled in circle on the right. Shade to the right. Shade to the left. There you go. All right, here we go. Now, how can we take it from verbal and put it into algebraic? Okay, so we're going to go from words, math, English, to Mathlish, right? We're going to go from words to numbers. So dancers on the Prior Lake team need to be no older than 18 and no younger than 14. So when I look at this and I read this, I think, you know what? They could be 18 and they could be 14. So when I'm going to write the compound inequality, I'm going to keep in mind my rule that the lesser number on the left, the greater number on the right, variable in between, because they have to fall between 14 and 18. They can be 14, so I can put the line underneath, and they can be 18. Now, some of you might find it helpful to graph the pictures before you put it as an inequality. That works too, because sometimes it's easier to say, okay, this is 14, this is 18, fill it in, okay? And it's got to be somewhere in between. Somewhere in between. Okay. All right, Harrison is collecting football cards. He estimates he has more than 250, but no more than 450. So if I want to look at it as a picture, sometimes it's easier to do that. He has more than 250, so it's going to go this way, but no more than 450. If he has more than 250, he doesn't have 250, but no more than 450. That could include 450, so that's going to be a filled in dot. So now I can take my picture and write it out as an inequality. Sometimes that picture really just helps with the understanding. And there's nothing wrong with that. I think in geometry, drawing pictures are something that you'll just do a lot. So whether geometry is next year or the following year, sketching pictures is always a great problem-solving strategy. And it works really well too with algebra. Okay, if water is not in a liquid state, it's either less than 32 degrees Fahrenheit or more than 212 degrees Fahrenheit. So we're talking about when it's a solid and a gas. Okay, we see the word or. I'm going to sketch this out just because it helps me visualize a little bit better. So if it's not in a liquid state, it's going to be less than 32. So I guess I'd have to confer with Miss Stark and Miss Kuchenmeister if it actually included 32. But I think I've measured stuff at 32 and that's where it's transitioning. So I might need to do some work on that. And then it has to be more than 212 degrees. Okay, because those graphs are going apart, that's telling me that it's going to be an or statement. So X is less than 32 or X is more than 212 when water is not in a liquid state. Cool stuff. All right, one more. Here we go. Kelly's having a birthday party. Okay, she has no more than $30 to spend on the cupcakes and the juice. If the cupcakes are $1.50 and juice is $2, let's write the inequality. Okay, so $30 is the max that she can spend. So what Kelly spends has to be less than or equal to 30. Okay, the cupcakes are $1.50. So $1.50 times the number of cupcakes plus $2 times the number of bottles of juice will get you less than 30. Okay. So that's my inequality. $1.50 times the number of cupcakes plus $2 times the number of juices has to be less than or equal to 30. Real life scenario, right? When you're budgeting, when I buy all of this, I have to be within my budget. Very realistic. Okay. So will Kelly have enough money to buy 12 cupcakes and 12 juice bottles? Well, $1.50 times 12 is $18, and $2 times 12 is $24. Yeah, looks like she's over budget by like 12 bucks. So nope, not enough money. Now, could I have filled this values into that inequality and solved it? Sure. I just chose to figure out how much juice was and how much the cupcakes were. So you get a chance now to work on your practice. Let me know if you've got any questions. I'll see you soon. Take care. Bye-bye.